Welcome back, guys. This video is going to be all about events. So last time, as you remember, let's take a quick look at how the game looks. So last time we had this crazy visual effect going on, so let's quickly turn that off because we definitely do not need that at all. So I'm going to take this outside of the game loop here, and I'm just going to set the color to be a gray. Okay, great. So as you remember, currently we have no way of interacting with the window whatsoever. So we cannot click any of these buttons to maximize the window, to minimize it, and to close it. We can't even get the window back if it's minimized. It's just a frozen window at this point. So in order to make our window interactable, we need to handle the events that the operating system is trying to send to our window and the events that our window is trying to emit. And that's actually a topic of operating systems and how they work. Basically, almost all operating systems have a system to handle events, and Windows, which is the operating system I'm using, is no exception. And SDL, being very helpful, has an abstraction over all of those different operating systems. So once we handle these events with SDL, we actually don't need to care about them at all for different operating systems. But if you weren't using SDL and you were writing your own code for this stuff, you'd have to write a different type of event code for each operating system. Okay, great. So let's take a look at this list I made for this video so that I don't forget any of it. So the first thing I have on my list is write the event loop. So in order to start handling events, we need to write something called an event loop. And that's going to live right under the main game loop we have here. And it's also going to be a while loop. And we're actually going to take a look at the wiki in just a moment. The call that we need to use here is called SDL poll event. And that's going to take in an SDL event structure, which is actually not a structure, it's a union, but I'm gonna get to that in just a moment. Let's call this event, and we need to pass this to SDL poll event, pass the address of it, and this is gonna return 0 or 1, depending on if there's a event that's waiting to be polled. So while this is not 0, we're gonna keep looping, and this loop is basically going to poll all the events that are waiting for us to handle them. And this alone will make the window interactable. It's at least going to make it not be a frozen window. So let's try to compile this. And let's run it. Now, as you can see, I can move the window, I can maximize it, make it full screen. I can make it be a different size. I can minimize it like that. But the only thing I can't do right now is use this cross button, because that's an event we need to handle ourselves. So that one doesn't work at the moment. Okay, so let's go to the wiki and let's do a search for poll events. And this has all the information you need about events. It also shows us an example here, which is exactly what we just did. It has the main game loop here and has the event loop right under it. So let's take a look at this event union that I just mentioned to you. So it's a union that contains structures for the different event types. So this event, SDL event union, can be any of these structures. These are actually structures of different types of events. And all of these structures have a type field. So if you take a look at, for example, SDL quit event, which is the one we're going to check for, it has a type. All of these have a type. Let's take a look at SDL keyboard event. It has a type. So we're going to use these to handle different kinds of events, which is actually the second thing I have on my list here. The first is writing the event loop, which we just did. And the second thing is handling the quit event, which is gonna let us use that cross button on the window. So let's take a look at this SDL quit event. So as you can see, the type here, it says it's quit in all lowercase letters. So we need to, inside of our event loop here, we need to do a switch on the event.type. And the cases we're going to check for are going to be this type here. So we're going to check for SDL quit. Case SDL quit. And firstly, before handling this in the right way, let's just do a SDL log here saying quit event emitted. Let's compile and let's run the game. And now when I click this cross, it's going to say quit event emitted. Great, so it's working. And handling this event is very easy. Actually, we just need to set this global running variable that we created to false. And that's going to make sure that we exit this main game loop. And in turn, that's going to quit the game because there's nothing else here. And you may think, like, why aren't we doing any kind of cleanup at the end here? Like at least calling SDL quit, which is a fair thing to say. And what I'm going to say is when you quit the game, the cleanup happens automatically anyway. So all the resources given to your game by the operating system will be taken away anyway. So even if you do some cleanup here, you're just doing extra work basically. Letting the game quit is actually going to be a better performance optimization for us. Okay, so what was I saying? Yes, so we set global running to false here. Let's compile and let's run the game. Now when I click here, the game's gonna close. Boom. That's it. That easy. Okay, so this is basically handling events in a nutshell. And now it's all about handling different types of events that our game needs. So okay, so we did the first one, we did the second one, and the next is to handle the window event size changed. So the second type of event is going to be a window event, which is called SDL window events. And this is actually a little bit more complicated than the quit event. Let's take a quick look here to SDL window event. Window event actually has sub-events in it. So a window event can be a window shown, window hidden, exposed, moved. All these different things that happen to your window are different types of window events that you can handle. The one that we want to handle is called window event size changed. So the way we do that is, so this is the window event structure, and it has, SDL is again being very nice and showing us how to do this actually. Before I explain it myself, it says look for event type, has to be a window event, which we're doing here, inside of here. And then we need to check for event.window.event again. Here, this is a pointer to an event, so it's using the arrow notation, but we're just going to use a dot. So let's do another switch inside of this case. And we're going to switch on window.event. And in here, we're going to check for the case window event size changed. Oops. Okay, and what we want to do is we want to print the new size of the window. And we can do that by copying this line. So this window event structure actually has the new size in it when this event is emitted. It also has the window ID, which we don't need to use. If you have multiple windows, which is usually not the case with the game, you can use this. It basically lets you know which window is emitting this event, but in this case, we're always going to have a single window, so I'm just going to get rid of this. So we're only going to log the new window size, and the window size is inside the data1 and data2 fields of the window event structure. And those fields are going to be different for each type of event. So for example, here, when you have the SDL window event moved, those fields are going to represent the new location the window moved. So just keep that in mind. Okay, so this will hopefully print the new window size when it changes. Okay, so we need to change this event to event dot. And let's run the game and take a look. So if I change the size, it's gonna tell me, oh, now the window is 883 by 720. And the reason I wanted to handle this event is because I want to change. First of all, we had these pound defines last time. I'm actually gonna ditch that idea. I'm actually gonna get rid of these. And I'm gonna define a structure called screenDim. And this structure is just gonna have two variables. One called two integers, one called width and one called height. And I'm gonna define a global screenDim variable here called screenDim. And we're initially gonna set this to be 1280 by 720. And in here, we're not gonna use these anymore. We're just gonna say screenDim.width and screenDim.height. Then, when the screen size changes, we're gonna update this variable. We're gonna say screenDim.width will be this event.window.data1. And likewise, the height is gonna be data2. So now we're basically updating this variable each time the screen size changes. So in the future, if you want to do stuff when the screen size changes, we can just do it here. And the effects will update the game because we're updating this screenDim variable. Let's actually call this global screenDim so that it's obvious that it's a global variable. And we can actually, instead of printing that, we can actually print the screenDim. Now, we're updating that variable correctly, as you can see. When I make it full screen, it's going to be almost my whole resolution, which is 1920 by 1080. It's a bit shorter on the height because it has this window thing. If you went truly full screen, which we can also do, but I'm just not going to do it right now, it would be 1920 by 1080. So yeah, that's the window event. Let's not log this every time. And the final thing I wanted to do is handling the key down and key up events. And those are going to be another case in our big switch statement here. It's going to be SDL key down. And we're actually going to handle both of these at the same time. It's going to be key down and key up. Let's take a quick look at the wiki. That's going to be an SDL keyboard event. So the type is going to be key. So it's going to be event.key.blah, blah, blah. And that blah, blah, blah is the stuff that's in here. So as you can see, it can be SDL key down or SDL key up, which we are checking here. And then what we want to check for first is this key sim here. And this key sim represents which key was pressed. So let's take a look at this. This has a bunch of stuff in here. The one we care about is this sim. So let's take a look at that. And this leads us to this very useful page that lists all the keys that we can check for. So all the keys basically have two different types of key codes. The first one is the scan code, which is the physical key. And this next one is the key code, which is, I think, the virtual key. So let's take a look. Yeah, so the key code is the virtual key code. Scan code is the physical key code. Don't ask me the difference. I don't really know. I guess the physical key code would be the physical key on the keyboard. So even if you remapped the physical key to be a different key, it wouldn't work. It would still fire the same scan code, but we don't want that. We want the key code. We want the user to be able to remap their own keyboard and still, get the correct key symbol. So the one we want is escape. That's the first key we're going to handle. So it's here. and this is the virtual key code. Let's copy this. Let's go back here. So it's gonna be, this is gonna be a long one. It's gonna be, so event.key.keysim.sim is gonna be what we look for. And that's also gonna be another switch statement. So let's do event.key.keysim.sim. And the case we're gonna check for is gonna be SDL key escape. So firstly, like we always do, let's just log and see that this is actually working. Escape pressed, let's say. Okay, I forgot the colon here, amazing. Okay, so now when I click escape or press, as you can see, escape pressed is being logged, and it's actually being logged twice. And the reason being is we're checking for key down and key up at the same time. So the first log is the key down, and the second one is when I release the key. So key down, and you can actually see the repeat happening here, which I'm gonna talk about too in a moment. But when I press and let go, it logs it twice, like I said. Okay, so let's take a look at the wiki again. And I'm gonna go back once. And as you can see, we have the state here, which tells us if it's pressed or released, which we're gonna use. And we also have this repeat here. So firstly, let's take care of this repeat, because I don't want to fire more events as I'm holding down repeat. So this is non-zero if this is a key repeat. So we want to check in here if event.key.repeat. Let's make sure that that's 0, because we don't want to do something if the key is being held down. So that compiles. Great. So let's try this again. So I'm gonna hold down escape, and this time, as you can see, we're not logging over and over again. And when I let go, it's gonna say escape pressed again. So let's also make the differentiation between pressing and releasing now. So we have the state field here, and it can be either SDL pressed or SDL released. So let's check for that too inside of this if statement. Let's say if event.key.state is equal to pressed, and then we can also say else if it's released. Okay, so now when I press escape, it's gonna say escape pressed. And when I release it, it's gonna say escape released. Great, so that's all we want to do right now with the key presses. And we're actually not gonna do anything when the escape is pressed. And when it's released, we want to quit the game. So that's the same as handling the quit event. We're just gonna set the global running variable to false. So now when I press escape, nothing happens. When I let go, the game quits. Amazing. So that's all the things I wanted to do in my list here. So as you can see, this is how we handle events with SDL. It's very simple, actually. It's just about, once you get the hang of how to do this, it's just about finding the events that you want to handle in your application and then just handling them. This is the same way we're going to do player input. We're gonna check for the W and the S key for the first player and the up and down keys for the second player. And we're just gonna move the paddles depending on the input. So thank you very much, guys, for watching. Make sure to subscribe, make sure to like, make sure to leave a comment if you have a question or if you want to suggest a topic for a different tutorial. I will see you in the next one.